Welcome dear friends to my video lecture on part 2 of Unit 6, namely logical reasoning in paper 1, NET paper 1. We already given the first one, very important ideas we are given in the first one. Now we are going to talk about inductive reasoning, deductive reasoning, all important points according to the syllabus, and we will be giving examples, questions, everything. Let us straight away enter into the topic. Right, inductive reasoning. Inductive reasoning is a fundamental aspect of human cognition, thinking, that plays a crucial role in our understanding of the world. So, inductive reasoning is a fundamental aspect of human. I mean, everybody thinks in this way only. Almost whether he is an educated person or uneducated person, we always have this inductive reasoning. Yeah, that's a fundamental aspect of human thinking aspect. It is a type of reasoning that involves making generalizations based on specific observations and patterns or evidence. It is a type of reasoning that involves making generalizations based on specific observations, patterns or evidence. Unlike deductive reasoning, which is concerned with deriving specific conclusions from given premises, inductive reasoning moves from specific instances to broader conclusions. Specific instances to broader conclusion. Let us see what it is. How to understand inductive reasoning? Inductive reasoning operates on the premise that if something is true in a specific set of cases, it is likely to be true in similar situations. So, inductive reasoning operates on the premise that if something is true in a specific set of cases, it is likely to be true in similar situations. You see, 90% of the swans are white. So, you tend to think that, the swan which would be in the next pond will be also white. This is how you are taking. So, if something is true in a specific set of cases, it is likely to be true in similar situations. Likewise, you take this example of the coin. So, you take 10 coins, from a bag, and you see all the coins are 2 rupee coins. So, you tend to think that the entire, bag is having full of 2 rupee coins. You come to a conclusion like that. So, if something is true in a specific set of cases, it is likely to be true in similar situations. That is called inductive reasoning. It doesn't guarantee the absolute truth of the conclusions drawn, but rather establishes a degree of probability. In the case of 2 rupee coin, that's the understanding. We are not very sure all the coins in the bag will be 2 rupee coins. We don't know. It doesn't guarantee the absolute truth of the conclusion drawn, but rather establish a degree of probability. From the evidence that 10 coins you have taken are 2 rupee coins, the entire bag will be having 2 rupee coins. You come to a conclusion like that is out of probability. There is a degree of probability. Probability only, not certainty. You must understand, this inductive argument goes with the probability. It may be true, it may not be true. That's the idea here. Through the evidence you are having, you come to a conclusion. Not necessarily it should be absolutely true. That is the idea here. Probably it is true, yes. So, the strength of the inductive argument lies in their ability to generalize from observed phenomena and make predictions based on those generalizations. So, the strength of inductive arguments lies in the ability to generalize from observed phenomena and make predictions based on those generalizations. What are the examples of inductive reasoning? Scientific discoveries. Scientific discoveries often rely on inductive reasoning. Consider the case of Isaac Newton observing an apple falling from a tree. From this singular observation, he developed the theory of universal gravitation, suggesting that objects with mass are attracted to each other. His initial observation led to the generalization of gravitational force, a foundational principle in physics. From one example, this Isaac Newton developed a theory based on one example he was having. He just saw apple falling from a tree. So that helped him to find the theory, isn't it? So from this singular observation, he developed the theory of universal gravitation. This comes under inductive reasoning. I hope you understood this. His initial observation led to the generalization of gravitational force, a foundational principle in physics. In medical research also, inductive reasoning is very much used. In the field of medicine, inductive reasoning plays a crucial role in identifying patterns and making diagnosis. When doctors encounter a series of patients with similar symptoms who respond positively to a particular treatment, they may generalize that treatment as effective for that specific conditions. So we use it in medical research. So when doctors encounter a series of patients with similar symptoms, one fellow goes with certain symptoms, another fellow also comes with the same symptoms. So 3 or 4 fellows, based on he comes to a conclusion because of his studies, because of his expertise, he comes to know what it is exactly they are undergoing or what sickness they are having. So he is able to generalize that treatment as effective for that specific conditions. So this is how inductive research is, inductive method is being used in medical research. Inductive reasoning is used in medical research. For example, the discovery of the link between smoking and lung cancer was based on inductive reasoning from a multitude of observed cases. You examine one fellow, he is having lung cancer and he is a chain smoker. Another one comes, he is also suffering from this lung cancer, he is also chain smoker. Like that, so many people come to the doctor and then they examine and then they see because of smoking they are having lung cancer. So this is how inductive reasoning is developed. So the discovery of the link between smoking and lung cancer was based on inductive reasoning from a multitude of observed cases. Then market research. The inductive reasoning is used in market research also. In business and marketing, inductive reasoning is applied to consumer behavior and market trends. By analyzing the purchasing habits and preferences of a specific target demographic people, companies can make predictions and develop strategies to cater to the broader market. For instance, if a study finds that millennials are increasingly choosing eco-friendly products, companies may generalize that environmental consciousness is an essential factor in consumer decision making. So if a study finds that millennials are increasingly choosing eco-friendly products, companies may generalize that environmental consciousness is an essential factor in consumer decision making. So this is how we, market research, we are using inductive reasoning. Then criminal profiling. In criminal profiling also we are using inductive reasoning. Criminal profiling relies on inductive reasoning to identify potential suspects based on a set of characteristics or behaviors exhibited by serial offenders. Law enforcement agencies use patterns from previous crimes to make educated guesses about a perpetrator's background, personality, and modus operandi. The way of doing things. Modus operandi, the way, the method of operation, modus operandi. So the law enforcement agency use patterns from previous crimes and then they make an educated guess. So that way in criminal profiling, inductive reasoning is used. While not infallible, inductive profiling has led to the apprehension of numerous criminals. It may not be infallible, but then inductive profiling has helped a lot in the, in the criminal profiling, to the apprehension of numerous criminals, to finding out of numerous criminals. Then environmental science, inductive reasoning is very much used in environmental science also. In the realm of environmental science, inductive reasoning is used to make predictions about the impact of various human activities on the planet. For example, climate scientists collect data on the increasing levels of greenhouse gases and their correlation with the rising global temperatures, right? So this is how inductive reasoning is used in environmental science. How this climate change happens, inductively they find out. So this information used to project future climate changes and the potential consequences of continued emissions. Then what are the challenges and limitations with regard to inductive reasoning? Inductive reasoning has its limitations and challenges. One of the key issues is that it doesn't provide absolute certainty. It will be probable, yes. It may be near to the truth, but may not be absolute truth. It may not be absolute certainty, in other words. So only the probability, the level, the degree of probability we can speak about, inductive reasoning with regard to its conclusions. So the conclusions drawn through inductive reasoning are probabilistic, probable, and there is always the possibility of encountering an exception to the observed pattern. What does this mean? Just because you have seen 10 coins as 2 rupee coin in a bag, there is a tendency to conclude that all the coins in the bag are 2 rupee coins. Take this example. So it's a probability only. Not necessarily it will be absolutely true. There may be 1 or 2 coins which may be 1 rupee coin or 5 rupee coins. We may not know. So that is why we talk about probability in inductive reasoning. So the inductive reasoning heavily depends on the quality and quantity of the data collected. A small biased sample can lead to erroneous generalizations. All these points are very important with regard to research. Furthermore, there is a danger of drawing hasty or unwarranted generalizations. Just because a particular pattern has been observed in a limited set of cases does not mean it holds true universally. It may not be true always. All the coins in the bag need not be 2 rupee coins. Only in limited cases it have been, you have observed 2 rupee coin, or you have counted 2 rupee coins up to 10 times. It doesn't mean that all the coins in the bag are 2 rupee coins. That is the idea here. A particular pattern has been observed in a limited set of cases does not mean it holds true universally. Universally it may not be true. Being aware of these limitations is the essential to avoid drawing flawed or over-generalized conclusions. Right? So we need to avoid drawing flawed or over-generalized conclusions. So how to conclude with regard to inductive reasoning? Inductive reasoning is a powerful tool that helps us make sense of the world around us. It allows us to generalize from specific observations, identify patterns, and make informed predictions. This form of reasoning has far-reaching applications in science, medicine, business, law enforcement, and many other fields. While it is not without its limitations, a thoughtful and cautious approach to inductive reasoning can lead to valuable insights and discoveries. It is a testament to the human capacity for learning and adapting through the power of observation and inference is a daily activity in our life. Without inductive reasoning, our life cannot go forward. So many things are happening because of inductive reasoning. In the science, even in ordinary day-to-day life, we always have this inductive reasoning. Yes, it may be false sometimes, but nevertheless, human mind is always drawn towards inductive reasoning. in a practical way. Then analogical reasoning, another aspect, another type of reasoning is analogical reasoning, comparison in other words. Analogical reasoning is a form of inductive reasoning that involves drawing parallels between different situations or cases. By finding similarities between observed instances and unobserved situations, we can make inferences. What are the examples of inductive reasoning? The sun example we can give. Here there is a specific observation, that is, you have observed the sun rising every day in your life. Yes, you have observed the sun rising every day in your life. What is the inductive conclusion? The sun will rise tomorrow. So far it has risen every day. So tomorrow it will rise. That is the inductive conclusion. In this case, your inductive reasoning is based on the repeated observation that the sun has risen daily, leading you to generalize that it will continue to do so in future. So this is how inductive conclusion is made. Now, scientific hypothesis. What do you mean by this? Specific observation. A scientist observes that all observed metals expand when heated. What is the inductive conclusion? Metals expand when heated. In this scientific example, inductive reasoning is used to form a hypothesis based on specific observations. The conclusion is not considered an absolute truth, but a working assumption that can be tested and refined through further experimentation. In market research also we do that. Specific data. A company conducts a survey and finds that the majority of its customers prefer product A over product B. What is the inductive conclusion? Product A is more popular among customers. Inductive reasoning is used in market research to generalize from a specific sample of customers to a broader claim about product preferences. Then medical diagnosis. Specific case. A doctor observes that patients with similar symptoms have a common underlying medical condition. What is the inductive conclusion? Patients with these symptoms may have this medical condition. In medical practice, doctors often use inductive reasoning to diagnose patients based on observed patterns of symptoms, even though that diagnosis is not certain until confirmed by further tests. Predicting weather also. Specific data, meteorologists analyze historical weather patterns and data to predict future weather conditions. What is the inductive conclusion? Based on historical data, it is likely to rain tomorrow. Weather forecasting relies on inductive reasoning by making predictions about future weather conditions based on past observations and data. So, based on historical data, it is likely to rain tomorrow. You come to a conclusion. What are the challenges and limitations of inductive reasoning? Just now we have seen that anyway. While inductive reasoning is a powerful tool for drawing general conclusions from specific evidence, it has some limitations. These include sample bias. Very important, these challenges and limitations with regard to inductive reasoning. Sample bias. What do you mean by that? Conclusions drawn through inductive reasoning may be biased if the sample of specific instances is not a representative of the broader population. See, for an example, if you want to study the personal values of the B.Ed students, you are taking sample of 1,200 students or 1,000 students from 20 colleges. Well, you are having the findings. Of course, you will be generalizing these findings to the entire community of B.Ed students. So, the sample, is too little, too small, it may not represent the general truth. What you have found out may not be applicable to all the B.Ed students. That is why in survey research and all, the sample size should be very big. If it is big, then the errors will be minimum. The idea is that. That's the sample bias. So, conclusion drawn through inductive reasoning may be biased if the sample of specific instances is not a representative of the broader population. In other words, the samples are not enough. If the sample size is very small, in survey research and all, there is a problem. The conclusions may not be very true. So the idea is that is called the sample bias. Then lack of certainty. Inductive conclusions are probabilistic, meaning they are subject to revision with the new evidence. They do not provide the same level of certainty as deductive reasoning. I mean, you can refine it, yes, more and more tests, you can do, and then you can refine it, you can even find out the truth also, but it may not be 100% true. That is the idea here. Lack of certainty. Inductive conclusions are probabilistic, meaning that they are subject to revision with the new evidence. They do not provide the same level of certainty as deductive reasoning. Then hasty generalization. Another drawback in inductive reasoning is hasty generalization. Speed. Very quickly you come to a conclusion. Drawing conclusion too quickly from limited evidence can lead to inaccurate generalizations, often referred to as hasty generalization. Very important concept. Right. Then counter examples. A single counter example can disprove an inductive generalization, illustrating the inherent fragility of inductive reasoning, inherent weakness of inductive reasoning. That is the idea. A single counter example can weaken the inductive generalization. That's called counter example. Now let us understand the meaning of deductive reasoning. So far we were talking about inductive reasoning. Let us talk about deductive reasoning. Deductive reasoning is a fundamental aspect of human cognition. It forms the backbone of logical thinking and problem solving. Very important one. Rooted in the works of ancient philosophers such as Aristotle, deductive reasoning is a systematic process of drawing conclusions from premises through a series of logical steps. So, deductive reasoning is a systematic process of drawing conclusions from premises. All men are mortal. Aristotle is a man. Okay. So, two premises. You are drawing conclusion from premises through a series of logical steps. All men are mortal. Aristotle is a man. So, Aristotle is what? Aristotle is mortal. So, deductive conclusion. Okay. Deductive reasoning. So, rooted in the works of ancient philosophers such as Aristotle, deductive reasoning is a systematic process of drawing conclusions from premises through a series of logical steps. Now, what are the principles of deductive reasoning? Premises, of course, how the premises should be formed. Deductive reasoning starts with one or more premises which are statements that are assumed to be true. That's very important. In the deductive reasoning, the premises should be true. At least they should be assumed to be true. So, deductive reasoning starts with one or more premises, statements, which are statements, true statements that are assumed to be true. I hope you understood. Deductive reasoning starts with one or more premises, which are statements that are assumed to be true. These premises serve as the foundation upon which conclusions are built. For deductive reasoning to be valid, the premises must be accurate. In the classic example of what I have given, all men are mortal, Aristotle is a man. So here the premises are correct. If they are correct, the conclusion should be correct also. Aristotle is mortal. The conclusion must be accurate, true. That is syllogism. A syllogism is a deductive argument that consists of three propositions, two premises and a conclusion. Syllogisms are structured in the following way. I already told you. Premise 1, all men are mortal. Premise 2, Socrates is a man. Conclusion, therefore Socrates is mortal. Then validity and soundness. What do you mean by this? Deductive arguments are evaluated based on the validity and soundness. A valid argument is one in which the conclusion necessarily follows from the premises. Soundness, on the other hand, not only requires validity, but also that the premises are modus ponens and modus tollens. What do you mean by this? Modus ponens and modus tollens. There are two concepts. There are two fundamental deductive argument forms. Modus ponens asserts that if the premise is true, then the conclusion must be true. I hope you understood. Modus ponens, if P is true, the Q is true. P is true, Q is true. So that is modus ponens. Asserts that if the premise is true, then the conclusion must be true. Whereas modus tollens conversely argues that if the conclusion is false, then the premise must also be false. That is called modus tollens. Modus tollens says if the conclusion is false, then the premise must also be false. The conclusion comes from the premises. If any one of the premises is false, naturally the conclusion should be false. It cannot be true. You got the point? So that is the idea here. That is called modus tollens. Modus tollens argues that if the conclusion is false, then the premises must also be false. What are the examples of deductive reasoning? Mathematics. The entire mathematics, comes under this deductive reasoning. Deductive reasoning plays a pivotal role in mathematics. Euclidean geometry, for instance, is built upon a series of axioms and theorems that are derived through deductive reasoning. For instance, premise 1, a straight line can be extended indefinitely. Premise 1. Premise 2, a circle is a set of points equidistant from its center. So what is the conclusion here? The circumference of the circle is 2 pi times its radius. 2 pi times it is indefinite. Infinitely it goes 2 pi. It goes point something like. So that is the idea here. This is a nice example of this deductive reasoning. A straight line can be extended indefinitely. A circle is a set of points equidistant from its center. So the circumference of the circle is 2 pi times its radius, and it is indefinitely going. There is no round number here. Okay, 2 into 22 by 4, 3.14, 3.14 other numbers will be coming like that. But normally we will be taking as 3.14. I think you understood that, no? So it goes like this. Straight line can be extended indefinitely. In the circle also there is a line, yes, okay, line. A set of points equidistant from its center. So the circumference of the circle is 2 pi times its radius. Scientific discoveries often involve deductive reasoning. For instance, Albert Einstein's theory of relativity is a classic example. Scientific discovery. Premise 1. The speed of light is constant. Premise 2. Mass and energy are equivalent. E equal to mc squared. Not that way. Now what is the conclusion? As an object's speed approaches the speed of light, its mass increases. So that is how you will conclude. As an object's speed approaches the speed of light, its mass increases. So from the above statement, this is how you arrive at in inductive reasoning, in deductive reasoning. Then deductive reasoning is also integral to legal systems. In a courtroom, lawyers employ deductive reasoning to build their cases. For instance, premise 1, the accused's fingerprints were found at the crime scene. Premise 2, the accused had a motive to commit the crime. So what is the conclusion here? The accused is a suspect in the crime. So this is how we must conclude in the deductive reasoning. Now computer science also. Deductive reasoning is crucial in programming and software development. In Boolean logic, the following example illustrates how it is used. Premise 1. If it is raining, I will take an umbrella. Premise 2. It is raining. So therefore I will take an umbrella. right? So this is how, this deductive reasoning, okay, right. What are the challenges and limitations? While deductive reasoning is a powerful tool for drawing logical conclusions, it is not without its limitations. Deductive reasoning relies heavily on the accuracy of the premises, and if the premises are false, the conclusion drawn from them will be also false. Also, deductive reasoning can be inflexible in dealing with uncertainty and complexity, as it typically follows a strict linear path. Now, how to conclude? We summarize what is deductive reasoning. Deductive reasoning is a fundamental aspect of human thinking, cognition, helping us to make logical inferences and draw conclusions based on premises. Whether in mathematics, science, law, or everyday decision making, deductive reasoning is a valuable tool for critical thinking and problem solving. By understanding the principles and applying them effectively, we can enhance our ability to make enlightened, logical decisions and contribute to the advancement of various fields. Some of the questions we will ask: what is the primary goal of inductive logic? Of course, we already seen that and we can get the answer correctly. That is to identify patterns and make generalizations. That's the primary goal of inductive logic. Inductive logic aims to identify patterns in data and make generalizations based on observations without claiming absolute certainty. Now, what is the key weakness of inductive reasoning? Key weakness of inductive. Just see for yourself all the four options. That is, inductive reasoning does not guarantee the truth of conclusions, and it can sometimes lead to incorrect or erroneous conclusions. So that is why it can lead to erroneous conclusions, because not necessarily 100% true. That is the idea here. Now, which type of inductive reasoning involves drawing conclusions about the future based on past observations? Which type of inductive reasoning involves drawing conclusions about the future? That is nothing but predictive inductive. From these four options we can take. So that is a prediction. Predictive inductive reasoning involves making future projections based on past observations. Now, what is the principle of uniformity of nature in inductive reasoning? Uniformity nature means, you see that once again the example of the bag full of 2 rupee coin. You take 10 coins, one by one, all are 2 rupee coins. So this is called uniformity of nature. Sometimes it may mislead also. So which is the correct answer? What is the principle of uniformity of nature in inductive reasoning? That is the first one. It states that nature is always uniform and the future will resemble the past. So that is why because of this principle only, you take some coins as 2 rupee coins in a bag, and you tend to conclude that all the coins in the bag are 2 rupee coin. So nature is always uniform and the future will resemble the past. That is the principle of uniformity of nature in inductive reasoning. Now, what is the term for an inductive argument where the conclusion is supported by a set of specific instances? That is hasty generalization. What is the answer? What is the question? What is the term for an inductive argument where the conclusion is supported by a set of specific instances? There is hasty generalization. Hasty generalization is an inductive argument where the conclusion is drawn from a small or biased sample of specific instances. Which type of inductive reasoning involves drawing conclusions based on similarities between different situations or cases? Which type of inductive reasoning involves drawing conclusions based on similarities between different situations or cases? causal inference, generalization, analogy, abduction. That is analogy. Analogy is a form of inductive reasoning that involves drawing conclusions based on similarities, similarities between different situations or cases. What is the primary difference between deductive and inductive reasoning? What is the primary difference? Of course, you must be knowing already. That is, the primary difference between deductive and inductive reasoning is the nature of the premises and conclusion. What is the nature of the premise? You know, if the two premises are true and valid, naturally the conclusion will be true and valid. No? That is the idea. If in inductive reasoning, sometimes it may not be possible. No? Whatever is said may not be 100% true. So the primary difference between deductive and inductive reasoning is the nature of the premises and conclusions. Which of the following is an example of analogical reasoning? That is C. No? Cats and lions are both members of the Felidae family. Cats are known for their agility, so lions must be agile as well. So here, what do you see here? Option C uses analogical reasoning. That is, cats and lions are both members of the Felidae family. Cats are known for their agility, as lions must be agile as well. No? That is the idea here. So option C uses analogical reasoning by drawing conclusions based on similarities between cats and lions. Now, what is the potential problem with relying solely on inductive reasoning in decision making? What is the potential problem with relying solely on inductive reasoning in decision making? That is, B is the right answer. What is B? This inductive reasoning may overlook important patterns and generalize from limited data. The data is very much limited. You know, the generalization may be a problem. Generalization may have problem, right? So it may overlook important patterns and generalize from limited data. That is the right answer. Relying solely on inductive reasoning can lead to hasty generalizations and overlook important patterns as it generalizes from limited data. Which of the following terms refers to a specific type of inductive reasoning that involves drawing a general conclusion from a finite set of observation or instances? It's a question, very tough question. Which of the following terms refers to a specific type of inductive reasoning that involves drawing a general conclusion from a finite set of observation and instances? That is enumerative induction. There is a concept called enumerative induction. Enumerative induction is a form of inductive reasoning that derives a general conclusion from specific instances. Which of the following statement is an example of a strong inductive argument? That is, you know, this A1, no? Which is the example of a strong inductive argument. Most politicians are honest. So this politician must be honest. You know, right? Most politicians are honest. So this politician must be honest. That's a nice idea, no? So inductive reasoning. A is a strong inductive argument, while the others are weak and flawed. Which type of inductive argument involves drawing parallels between two or more similar cases to draw a conclusion about a new case? That is analogical reasoning. Analogical reasoning involves drawing conclusions based on similarities between cases. Which fallacy occurs when an inductive argument's premises do not support its conclusion, leading to an invalid argument? Which fallacy occurs when an inductive argument's premises do not support its conclusion, leading to an invalid argument? That is hasty generalization. A hasty generalization is a fallacy in inductive reasoning where the premises do not sufficiently support the conclusion. That is called hasty generalization. In inductive reasoning, what is a counter example used for? We already seen that. That is to weaken or challenge the argument's conclusion. That is counter example used to that is weakening the argument. That is the idea here. We have already seen that. What is the main goal of inductive reasoning? That is to establish, to increase the likelihood of conclusions being true. That increase the likelihood of conclusions being true. Inductive reasoning aims to make conclusions more likely or probable, but it doesn't guarantee their truth. Which type of inductive reasoning involves making predictions based on observed patterns? Which type of inductive reasoning involves making predictions based on observed patterns? That is generalization. Generalization involves making predictions about unobserved instances based on patterns in observed instances. So the generalization involves making predictions about unobserved instances based on patterns in observed instances. What does this mean? I am just having the sample of B.Ed students, 1500 samples perhaps. But I am trying to generalize for the entire family of B.Ed students. So the generalization involves making predictions about unobserved instances. See, my aim is to study the entire population, entire group of B.Ed students in Tamil Nadu. But then I am taking only 1500 students as a sample. So the generalization involves making predictions about unobserved instances based on these 1000 or 1500 observed instances. I hope you understood this. So that is the idea here. What type of inductive reasoning involves making predictions based on observed patterns. In analogical reasoning, what is the role of the analog or source domain? In analogical reasoning, what is the role of the analog or source domain? So it is this one. It serves as the basis for drawing conclusions about the target domain. So analogical reasoning, what is the role of analog and source domain? That is, in analogical reasoning, the analog or source domain is used as the basis for drawing conclusions about the target domain. In analogical reasoning, the analog or source domain is used as the basis for drawing conclusions about the target domain. What is the primary weakness of induction through enumeration? What is the primary weakness of induction through enumeration? So that is, it often leads to inaccurate conclusions due to limited sampling. As I already told you, 1000 students, whereas there are 10 lakh students in Tamil Nadu, that way. So it often leads to inaccurate conclusions due to limited sampling. Induction through enumeration can lead to inaccurate conclusions when the sample size is limited. What is the principle of simplicity in inductive reasoning? So that is this one. The simplest explanation is often the best. That is the principle of simplicity in inductive reasoning. That is, the simplest explanation is often the best. Now, what is the difference between strong and weak inductive arguments? Strong and inductive arguments. That is, strong inductive arguments provide more support for the inclusions, whereas weak arguments provide less support. Very simple it is, of course. What is the purpose of the principle of uniformity in analogical reasoning? What is the purpose of the principle of simplicity, uniformity in analogical reasoning? That is, to ensure that the analogy is valid and relevant. The principle of uniformity ensures that the analogy is valid and relevant by highlighting similarities between the source and target domains. Which of the following is not a limitation of inductive reasoning? That is, it relies solely on deductive logic. Which of the following is not a limitation of inductive reasoning? That is, it relies solely on deductive logic. That is, inductive reasoning is a distinct form of reasoning, does not rely on deductive logic to establish its conclusions. Then what is deductive reasoning? That is, drawing a general conclusion from specific premises. Drawing a general conclusion from specific premises. That is deductive reasoning. Deductive reasoning involves drawing specific conclusions from a set of general premises or principles. It is a logical process of deriving conclusions that are necessarily true if the premises are true. Which famous philosopher is often associated with the development of deductive reasoning? That is Aristotle. Aristotle is widely recognized for his contributions to deductive reasoning and formal logic. In a valid deductive argument, if the premises are true, then the conclusion is true. Guaranteed to be true, very important, by all means it is true. If the premises are true, conclusions are categorically true or by all means true, guaranteed to be true. It cannot be false. If the premises are true, it has, the conclusion should be true. It cannot be false. In a valid deductive argument, if the premises are true, the conclusion must be true. It follows necessarily from the premises. Which term refers to a syllogism with a false premise or a logical flaw? That is fallacy. Which term refers to a syllogism with a false premise or a logical flaw? Of course, we already seen that fallacy. So, a fallacy is a mistake in reasoning that renders an argument invalid or unsound. In deductive reasoning, what is a syllogism? In deductive reasoning, what is a syllogism? It's a three-part argument consisting of two premises and a conclusion. Take the example, all men are mortal. Aristotle is a man. So, Aristotle is mortal. He can die. That is the idea here. So, in deductive reasoning, what is a syllogism? That is a three-part argument. Two premises, one conclusion. Three-part argument consisting of two premises and a conclusion. A syllogism is a three-part argument consisting of two premises and a conclusion, typically used in deductive reasoning. Which type of deductive reasoning involves creating a specific conclusion from a general principle? That is hypothetical syllogism. Which type of deductive reasoning involves creating a specific conclusion from a general principle? How? A hypothetical syllogism involves creating a specific conclusion from a general principle or conditional statement. From this, creating a specific conclusion from a general principle. I think answer seems to be incorrect. Probably it should be inductive reasoning. Maybe it is not the correct one. C, A is the correct one. That is, a hypothetical syllogism involves creating a specific conclusion from a general principle or conditional statement. In the modus ponens deductive argument form, what can be inferred if the antecedent is true? In the modus ponens deductive argument form, that is, the consequent is true. In modus ponens, if the antecedent is true, then the the consequent must also be true. If P, Q, P is true, Q is true. That is called a modus ponens, right? If the antecedent is true, then the consequent must also be true. Which type of fallacy involves attacking the person making an argument rather than addressing the argument? So already we have seen that is ad hominem. Which type of fallacy involves attacking the person making an argument rather than addressing the argument? Is ad hominem. Ad hominem fallacy attacks the person making the argument instead of addressing the argument's merits. Which deductive argument form involves affirming the antecedent to reach a conclusion? That is a modus ponens. What do you mean by modus ponens? Modus ponens involves affirming the antecedent to reach a conclusion. It follows the pattern: if A, then B. A is true, therefore B is true. That is modus ponens. If all humans are mortal and Sarah is a human, what can we deduce? Sarah is also mortal, as we already seen in the classical example. No? Deductive reasoning concludes that if all humans are mortal, then Sarah, being a human, must also be mortal. In a valid deductive argument, if the premises are true, then the conclusion is true. No doubt about it. We already seen that. In a valid deductive argument, all men are mortal. Aristotle is a man, so Aristotle is mortal. This is a valid deductive argument. If the premises are true, the conclusion must also be true. What is a fallacy that occurs when an argument's conclusion merely restates the premise? We are already seen. What is the ending becomes the beginning, like that is circular reasoning. Circular reasoning is a logical fallacy where the conclusion is essentially a restatement of the premise. The conclusion becomes the restatement of the premise. Modus ponens is a valid form of deductive reasoning. What does it assert? Modus ponens is a valid form of deductive reasoning. What does it assert? If P then Q, Q is true, therefore P is true. No. If P then Q, P is true, therefore Q is true. That is the correct answer, right? That is P. No? If P, Q. P is true, then Q is true. That is called modus ponens. Modus ponens affirms that if the premise, if P then Q is true and P is true, then Q must also be true. What is a common strategy in deductive reasoning that involves considering multiple possible outcomes and eliminating them until only one remains? What is a common strategy in deductive reasoning? That is reductio ad absurdum. Reductio ad absurdum. What does this mean? Reductio ad absurdum is a technique where one disproves a statement by showing that its negation leads to an absurd or contradictory results. So that is called a reductio ad absurdum. So what is the technique here? One disproves a statement by showing that its negation leads to an absurd or contradictory result. That way disproves a statement. Okay, which of the following is not a valid form of deductive reasoning? That is a post hoc fallacy. What is the meaning of this post hoc fallacy? The post hoc fallacy is not a valid form of deductive reasoning. It is a fallacy that infers causation based on temporal sequence. Deductive reasoning relies on valid logical structures. The post hoc fallacy is not a valid form of deductive reasoning. It is a fallacy that infers causation based on temporal sequence. Deductive reasoning relies on valid logical structures. What is deductive reasoning? That is a form of reasoning that uses general principles to make specific conclusions. Deductive reasoning starts with general principles or premises and uses them to reach specific conclusions. It is based on a logical structure that ensures the conclusions are valid if the premises are true. Which famous philosopher is often associated with the development of deductive reasoning? That is Aristotle. We already seen that. Aristotle. That is, Aristotle is one of the most famous philosophers associated with the development of deductive reasoning. He formulated the syllogism, which is a fundamental tool in deductive logic. Thank you, dear friends. Let us meet in another video. I think one more video is that is Indian logic. So far we have covered everything almost. Now the last part is remaining, that is Indian logic. Dear friends, so we are having the last, next video will be the last part of Unit 6. So far we have given 2. No? With this there are 2 videos. We have almost covered the first 4 points in the syllabus. The last part will be covered in the next video. God bless you abundantly, dear friends. Please go through everything so that you understand and then you are able to crack NET so successfully. Thank you very much for your presence here.